Hi. Should we start? Because we just have a 30-minute schedule for this meeting. I think this meeting will go off after 30 minutes. Already we have spent around 3 minutes, I guess. We'll just try and get this screen here. Okay. Okay. Here we go. Okay, let's start with the things. We just start with the monolithic versus microservices presentation out here. Just a bit of monolith out there about in just quick few lines. Is basically a single language program, generally speaking, and yes, UI of course can have a different set of languages like HTML and JavaScript and all. But in general, the backend has got the single language and it has got the single code base as such. Moving ahead with the microservices, yes, it can be a single language or a multi-language, yes. But the main idea of microservices would be the independent functional units that we have there, meaning they have their own databases. They can be restarted or restarted just anytime as needed. So even if they are replicated across the implementing server, they can any one of them can stop any one of them if even if it goes off if it fails, it can be restarted. So not the unlike the monolithic that the whole application goes off the screen. So just coming quickly to the basic characteristics, what we speak about the microservices, like the microservices are like modular in nature. So any microservices based architecture has got small microservices and one composite UI there. So it becomes modular, as I said. So so any one of them goes down, okay, yet again they can be restarted out there. It can manage easily and stuff like that. And the thing is, they are flexible. If not flexible, meaning yes, all these services can be independently replicated as they need it. For example, sometimes the the in an e-commerce application, let's say there may be more number of logins, there may be more number of people who use application card. So and there may be people there may be some products out there who are not browsed at all. So we may not need all this, let's say 15 replicas for all of them. Maybe the login can have 10, the application card can have 15, some categories can have 10. So the replication factor of these services can be literally flexible out there. So another thing, the beauty of this microservices is they are robust. Robust meaning the high availability of these services can be maintained. Meaning if any one of the services goes down, not that the entire application goes down. So that's the very beauty of this microservices out there. Another thing is clear ownership of code. So today's world, we all develop in a DevOps or agile environment where we have a small teams taking ownership of the code they develop. So here the microservices allow the greater ownership of this code, in fact, and the boundaries are very clear about it. So that's how they have a clear ownership of code as such. So quickly, we'll just see how we'll take up a small example of a small dummy calculator. In fact, it's a nascent thing, but the whole idea is to see how the monolithic application can be split into the microservices on a microservices architecture, and what all is all about. Then we'll quickly have some discussion over the uh, microservices versus monolith debate. So pulling around the code. The application as such is very basic. As I said, we just want to see what's the difference between this monolith and microservices, and how the monolith application can be broken up. In fact, this is a Flask application. It has 4 basic methods which calculate sum of the 2 inputs. Then we have subtraction out there. Then we have multiplication, and then we have division. Now, as such, this by default it is to run on 0.0.00 IP. Then we have a Docker file here, which is saying that okay, copy all the files into the /app directory. Then /app is the working directory. Please install the whatever requirements of this Python applications are there into the Python environment via pip environment, and then we run a command out there. Since we have no port to expose out there, we are not exposing any port as such. So this is monolith application here. So what we can see is all 4 methods are there in the same code base, meaning this is more difficult to manage if in a big scale on a if it is if we are working on a big project. And of course, if one of the method fails or some error occurs, the whole application goes down here. So we just see the microservices version of this.
Ashish, can you set the auto join or something so people can join? They are trying and they cannot.
Are they waiting? Okay,
yeah,
let me.
For example, is trying to join and
thanks.
cannot.
The meeting controls. Okay. Okay, I think somebody is taking time to join. Okay, for those just who joined us late, I was just discussing we just had a brief presentation over the microservices and the monolith debate, and just we are going through the application as such here, which is basically a small calculator style application developed in Flask, and the respective Docker file. So as such, you can see in the monolithic version, we have the sum, addition, subtraction, and the multiplication and division methods out there in a single file, single application as such, running exposed via a single port, single IP. We'll quickly go through the microservices version of it. As such, we can see there is a addition method called as sum. This is the application which will be responsible for the addition methods here. Then we can see a Flask based microservice. Yes, in structure it looks very much like a web service, and yes, it is exposed on port number 5000 via the same IP, that is 0.0.0. And there is only one method which is which can be accessible at /sum. Similarly, we have a Docker file out there. Let's see, Docker file out here for this method. This whole thing is a functional unit now. Then this is one more functional unit, that is subtraction. Respectively, we have a subtraction method out there. Then we can have a multiplication. Then we have a division method as such here. So it is it just looks the same thing. Just the methods have been exposed out there in a different service. So what exactly happens is now what we do is for the monolithic version, we run the command for docker.build for -t calculate monolith dot. And when it's built, we run this application as a Docker run calculator monolith. For the microservices version, what the picture changes, in fact, we have 4 Docker files now for each of the modules, that is for each of the web service that we have called as sum for the sum. Then we have for the division and multiplication, then subtraction as well. So these are the respective things. So if we want, we can just build up and build this Docker files and see, or else we continue with our discussion directly. How you prefer? Because I guess we have yeah.
I think you should go on, because seeing how some Docker files are built is not.
Okay, you want me to build it? Okay, no issues.
No. Just go on and you can work with the ones that you have already built.
Okay, got it. So as such, this microservices versus what happens many times, as we were discussing on the chat as well, many a times the things happen that there is a big database out there which is probably based on old structures, like the traditional SQL databases, and those are on the, yes, they may be on the mainframe as well at times. So will that be a microservice? That's for what happens with that, in fact. Well, the big answer will be there. In that case, we will be replicating that database if possible, or splitting the database into different parts, in fact, for each of this microservice we have it. So what that means, meaning all the database require as far as possible should be with the web service. It should be with the microservice itself. If we are able to split it across, yes, well and good, why not? But as far as possible, it has to be a same functional unit. That's what is the idea behind it. And monoliths, as for small applications, it was very beautiful thing, no doubt about it. Many a times, in fact, many startups start with a monolith architecture and then probably move on to the cloud. So microservices architecture, yes, that's always possible out there. And another thing which was coming to my mind was with regards to microservices. The Microservices Act are, in fact, many a times if we have a fault tolerant code out there, yes, the replication or the restart of the services was one aspect of the entire fault tolerance out there, and the robustness out there. And but in fact, they can be routed to another geographic area completely. In fact, we don't have to worry about it. So for example, nowadays we have a different clouds, in fact. So for example, if we have copy of this application running in a, let's say, Mumbai region, and let the another copy running in the California region on the west coast or of US, or so one running in Spain, one running in London region. So what happens is, any one of them service, if any one service goes on, if one copy of this application goes on, yes, the other one takes on. And in fact, this is in fact multiplied to the individual services. That's what is the beauty out there. And if we take all this Docker files into the Docker containers onto the Kubernetes, something like Kubernetes, well, nothing like it, because Kubernetes always is able to manage these services and this container on its own. In fact, in case of failure, some basic things, of course. The more complex things have to be programmed. In fact, that's true. And of course, if we take it one more step ahead into something like our Cloud Foundry or OpenShift, yes, nothing like it. We have reached the next level of our cloud native applications as such out there. So these can, so as far as possible, so you can say, we are in a position to imagine that yes, these services are, as far as possible, not exchanging any data as such. So that is how the traditional transaction mechanism of monolith application changes here. So this means that as far as possible, these are all stateless. They have a limited state with respect to their own databases. So something more recently, we had a small discussion on this on our chat as well on the Slack channel. There are some kind of APIs available in Kubernetes to deal with stateful applications. Yes, they are the additional functionality offered by the Kubernetes to have this kind of things, but more or less they have a very limited state, because of the nature, because we want to, if they exchange too much of data out there, we may not be able to have the robustness into picture, because in case of failure, we might lose the entire transaction out there as such with that. That's all I think from my side. Anything you all will like to add, or you have any queries so that I can answer or something?
Hello, Mr. Ashish.
Yeah, hello.
I wanted to ask a question. Like, I was doing an internship in a startup, and they started with a monolithic structure. Okay, it was a MVC application, so that was completely like monolithic structure. But they were also using different APIs or services, which is like a microservice, according to me. So I was thinking, like, what will be in the long run, what will be they doing? Because they already had some type of services which are in the monolithic part of their application. So how they are going to like completely migrate to microservices, or are they going to stick to that, like half monolithic and then the new functionality, the addition in?
Well, ideally they will have to go step by step. First is the monolith application stays like that, and the consuming application at the consumer end, whether of this APIs, they split into the microservices, small web services. Once that happens, they will, and the next step, they will break this monolithic applications into another chunk of microservices. If the company has resources, then well and good, they can do it simultaneously. No doubt these days we have this thing called beta servers and all. So very well they can do it that way.
Okay, I understood. Thank you.
I can also, because I've been there in one company like that, and I happen to be the one that had to cut one piece of the monolith and migrate it. And it always depends on the on what you need to do with this piece of logic. Because, for example, if you have a different team that has to handle this thing, or it evolves very differently, because, for example, they are using, I don't know, one provider, and then they know they might change to another provider, or they need a different language or something like that. Then what you end up doing is, first you are supposed to have everything modular. So you separate the module and then you move it out. But that's something that you do if you need to, because once you do that, everything that was a local call now becomes a remote, and then you have to take into account timeouts and retrying and whatever. So, but it's very typical for startups to start with a monolith because it's faster and you just have a couple of guys. So no, you don't have to start with tons of different artifacts. And then what you have to do, even if you are using a monolith, is have everything very nicely in modules. And then when you detect that, this part is going to, be hit a lot with a very heavy load, and then you need to separate it because you don't want to scale this other part, then you cut it up and separate it. And in these discussions, we always talk a monolith or microservices, but the truth is, in many places, you have a mixed thing, because when you have a monolith, in many cases, you don't have just one, you have a big one, and maybe you have some small services that do, I don't know, the payments, because they have some security requirements. So they usually are already in a separate part. But then you start cutting pieces, and then if you are Netflix or you are Facebook, then you end up with thousands of microservices. But if not, you just cut the pieces that you need to, because it's a very heavy, it's a tons of overhead for having microservices. So you just do it when you need to.
Okay. So we only cut out the pieces that we need to scale, and we don't want to scale the other functionalities. So that's why we cut that out.
Yeah, because, for example, scaling the UI for handling millions of requests is useless if you just can have a couple of them.
What happens is
in the database with millions of requests is not going to work. So you just scale the one that you need.
In fact, in case of where applications where we handle user data, particularly in different regions, they usually go for a separate microservices, because what happens is different regions have different laws as such out there. So that's the first thing they take out there. So nothing is the rule that you have to start with monolith and then move on to microservice. In fact, you can start with one small microservice unit and then probably keep on adding another microservice unit out there. In fact, that is also another approach to the entire situation. For example, not exactly it's not an example of microservice as such, but recently Vivaldi, the browser out there, they started with a browser, and then they started adding the other components to it. So that can be done always.
Yeah, I understood this. Thanks, everyone.
Okay. Daniel, would you like to add something? We have last 3 minutes with us.
No, that's pretty much it. For example, I've worked in big companies with that were moving to microservices, but where I work now, basically my whole team is me and sometimes another guy or another one. So I don't have there's no point for me going microservices. It adds a ton of overhead for me. I have to manage something like 30 applications. If I had to cut them down 5 pieces each, then it would be 150. That's not going to happen. So you just have to choose the one that you need and you're able to manage.
Exactly. Then
Okay.
the most interesting part is when we scale up, these transactions become more difficult to handle in monolithic case, in fact, and they go much easier, in fact, in the microservices when we are talking of the scaling of things.
I have a question. Hello.
Yeah.
Would it be right to then say that if a company happens to for a prolonged time still based on monologue, as in there's no prospect of expansion, because it seems with expansion and growth comes, as in there's no escaping microservices. So would it be right to say if a company has practiced the monolithic approach for a long time, does it really mean there have not been growths?
Yes, the monolith style does makes it difficult to expand, in fact, and to add services, in fact, because what happens is when it comes to scaling, that is always an issue, in fact, with these things. And of course, there is no single point where we are consuming this microservice into it. So we lose the single point of interaction that these different functional units have. So most of the time, what happens is my X microservices communicating only with Y, and the Y1 is again communicating with Z. So there is a peculiar sequence, we know it, how they are communicating with each other. What happens in a case of monolith is this code management becomes very difficult, and we have to go on duplicating this communication of these services, different services, or different functionalities all over the monolith app, in fact. So the code management becomes more difficult, and then again the other issues start. So very objective of the object-oriented programming or the agile environment or the DevOps environment goes away with it.
I would say that in this, I'm not really convinced that the monolith is wrong in this regard, because if you're not able to keep your monolith clean and modularly separated, then you're not going to be able to do it with microservices. So yeah, it's easier to get it wrong when you are in a monolith, because it's easy to mix code in calling one place and calling another. But the thing is that I wouldn't go just for that. I mean, I would go microservices if you really need the scaling or different teams, but just for, having clear communications, I mean, with the overhead that they add, I wouldn't go there. I mean, I know people do, but
yeah,
I mean,
some applications it can cause a problem, some typical things.
ooh.
Okay.
All right, thank you.
Okay, let's disperse. I think this meeting will otherwise automatically end off sometime, because this is running on a free account, so it will run off automatically within 40 minutes or something. Yeah. And anything we have to discuss? I think we have covered most.
Just thank you.
Okay. All right.
Okay, let's disperse. Thank you all.
Thank you.
Thank you.
Thank you.